Hello, everyone. Thank you for tuning in for our Cloud on Air sessions. Today we have 3 sessions, and I have the honor to do the first one about Cloud Spanner. After me will be a session about storage, Google Cloud Storage, and then thereafter about G Suite hardening, security hardening. I'm Robert Kubis. I'm a cloud developer advocate on the Google Cloud Platform. We understand our job as like a bidirectional job between the developers that build on the Google Cloud Platform and the developers that build the platform for you. What are we going to talk today about? Today, I'm going to do an introduction on Google Cloud Spanner. So I will start off with what Cloud Spanner is and where it comes from. I'm going to talk about how it works, like behind the scenes. I'm going to give you a small demo of like how you can get started on Google Cloud Platform and on Cloud Spanner. And at the end, I'm going to talk a little bit about some use cases and industries and verticals where you can use Cloud Spanner. All right, so let's get started. So what is Cloud Spanner? Imagine the scenarios that you have an application that grows over time. It gets viral, and like a lot of people are using it. And this system is backed by a relational database, right? So for instance, you have billing data or any kinds of things like payments and things like that. At some point, like you would need to scale your database to like cope with the traffic that you're getting. So you have 2 options. You basically look at either scaling up your relational database, but this has a ceiling, right? Like you basically have to wait for your cloud provider to provide a bigger machine or for your hardware vendor to provide a bigger machine, and then you have to move everything over. Very, very complicated. The other option is that if you outgrow your vertical scalable solution, you're looking at other solutions which are scaling horizontal. So you're looking at usually at NoSQL databases where you scale horizontally. But by scaling horizontally and going the NoSQL way, you're giving up some really, really nice features about relational databases. So in between these two, you have something that is called sharding, where you can shard a relational database, but you give up a lot of the qualities as well for the relational database, and it gets really, really complicated. So we actually were faced with exactly that problem here in Google. Our ads business was running on a sharded MySQL, and we needed to find a solution which enables us to scale at the rate we were scaling and growing the company without having interruption, without taking down the entire database. You can imagine, like Google is a 24/7 business. And we cannot afford like basically taking our system offline for maintenance, for schema upgrades, or for migrating from one system to another. So after like we had like our system like sharded for many years, and like the last shard took 2 years, we built actually a new system which were giving us these attributes that we were looking for. A system that can scale horizontally, is globally distributed, and strongly consistent. So please meet Cloud Spanner. Cloud Spanner is actually the system that we are using inside of Google. So Cloud Spanner we have used for many years inside of Google, and we now make it available as a product, as a fully managed product under the Google Cloud Platform umbrella. So just to recap, what are the features of Google Cloud Spanner? It is an enterprise-grade database. It is globally distributed. It is strongly consistent. We don't sacrifice anything there. And you combine the benefits of a relational database with the horizontal scale. So you get a lot of the features that you're familiar with from a traditional relational database. So things like asset transactions, things like the structured query language, and you get also an SLA from us that is up to 5 nines of uptime. So this is about 23 seconds per month that we allow as a downtime. So many questions that we get asked is like, how does Google Cloud Spanner compare to either traditional databases, traditional relational databases, or to like the more newer modern one, the non-relational, so-called NoSQL databases. So you here see a table where we compare a couple of the attributes of these 2 databases. And I want to start with a relational database. As we saw in the first scenario, like in a relational database, you can only scale vertically, right? You can add like main memory, you can add disk, and you can add CPU, but at some point you reach a ceiling, a scalability ceiling. And if you want to stay relational, what you had to do is basically shard your relational database. So you basically say, okay, I'm gonna have like a part of this table there, part of this table on a second database, and then you pull out all the nice features from a relational database, like ACID transactions and referential constraints, and you have to re-implement these things in your application. So it's a lot of things that you have to deal with, and it's a lot of like operational overhead. So basically, if you look at a relational database system, it's not really scalable in a sense, right? It's really difficult to scale. Now, a lot of companies, they went like, okay, scalability is something I cannot sacrifice on. I need a scalable database. So they went the NoSQL way. NoSQL has a lot of nice things. You have like a more structural flexibility in your schemas, and you can actually distribute it under like to many nodes and horizontal scaling. But none of these traditional NoSQL databases has actually like a strong consistency across multiple regions and is still usable in the sense of like that it has low latency. Of course, there are databases, NoSQL databases, where you can tweak the consistency model and can decide how much consistency you want to have for your queries. But still, it's really complicated, and usually it gets very slow if you want to have a very strong consistency for your NoSQL databases. Now, the other thing is like replication. For a traditional database system, you can replicate to multiple instances and then use these instances for like a read-only replica. By that, freeing up your master node from some read performance that it usually uses up, and then can actually use more writes or do more writes on these on your master node. All right. So how does Cloud Spanner actually work? I want to start with like a logical architecture overview about Cloud Spanner. So you start with Cloud Spanner with an instance. So an instance is basically your resource pool, your compute nodes and your storage. And in this instance, you can create databases. So you can create, I think, about 1,024 databases and then about 2,000 tables in each of your database. All these databases and tables live in this instance. So this is your resource pool, and you can create multiple databases. Now, this is something that you're familiar with from a relational database. Now, there is another structure which is somewhat hidden from you, but we talk about it, and that is actually splits. So splits are basically where we take a table and order it by your primary key alphabetically or lexicographically, and then we take ranges of your table and split it by ranges. And that enables a really cool thing in Cloud Spanner. So what are we doing with this? So as mentioned, you get with an instance a resource pool of compute node and storage. Now, what we can do is basically replicate all this in multiple zones, and by that get a high availability and also some scalability in terms of read that we can perform. Now, to get like high read and write throughputs, we actually use these splits and distribute them across like the computes that are available. And by that, we have multiple computes basically being able to manage your reads and writes. So what we have here, you can see as we separate the compute and storage, we have 3 zones. So this is a schematic for a regional instance. Now, in my regional instance here, I choose 3 nodes. So I have 3 nodes replicated to all 3 zones. So in total, you get 9 compute nodes. Now, what is really important for these splits, so these like parts of your table, these ranges, is that there is exactly and never more than 1 compute node responsible for a split. And we do this by using paxes. So we use basically, here in this example, I have the split one. I have in each zone 1 compute node who's responsible for that split one. And then from these 3 nodes that are responsible for split one, I need to pick a leader. So in this case, we use actually paxes, which is a consensus algorithm to choose a leader in this group. But as I mentioned, it's really important that we never have 2 leaders for a split. So how do we do that actually performantly? And that's where true time is coming in. So you see, true time is something that we invented inside Google to be able to have something like a global wall clock time. So let me talk a little bit more about true time. So true time is basically what we do all over the world globally. In our data centers, we have GPS and atomic clocks. And what we need actually is we need something that we can trust all around the world. So let me give you an example. Imagine you have your friend with you and you compare watches and you synchronize these watches. And then you went off and you meet again after a week or let's say a month. Your watches will have drifted. Let's assume it's not a smartwatch that resynchronizes by itself. Let's have one of these old analog watches, right? So they will drift from each other. And this drift is actually dangerous in the sense of, like, if I trust these locks, I have actually two different times in two different places. And by that, I could have two leaders for a split and get inconsistency. So we needed something that we actually can trust all around the world. So we invented true time, which gives you actually not a specific time, but it gives you a range of time. It gives you an upper and a lower bound for a time that is either passed or not passed all around the world. So let me be a little bit more concrete here. So true time basically quantifies the worst possible error drift between data centers. You get a lower bound. That lower bound defines that this timestamp has passed all over the world. And you get an upper bound, which is a timestamp that has passed nowhere in the world. Now, with these two timestamps, you can actually make sure that you have never more than one leader for a split, which is really, really cool. So to synchronize actually our atomic clocks, we use GPS time masters in our data centers. These are synchronizing our atomic clocks. And then these atomic clocks, basically, when we get a true time for Spanner, but also other use cases in the Google Cloud Platform, we ask a subset of time masters, so the GPS time masters and atomic clocks. And then if there's any outlier, we just say, like, okay, this is a bad time master. We don't trust it. We take it out. But basically, since we have a subset of this time master, we basically take the majority of that. Now, in a normal operation, these atomic clocks drift by about 50 microseconds per second or 200 microseconds per second. And we resynchronize them about every 30 seconds. Now, some of you might ask, like, what happens if like all our time masters go down in the data center? Now, we can actually ask true time timestamp from a different data center, and we just calculate in the latency it takes to travel to this other data center and get the true time timestamp. What that means is the epsilon, so the range between the upper and lower bound, gets bigger, and by that, the database will actually slow down, but it will not stop. It will still be operational. All right, so what is the data format in Google Cloud Spanner? So the data format is actually what you're very familiar with. We are using for Google Cloud Spanner SQL ANSI 2011 with a couple of extensions. So you can use just the normal DDL as you are familiar with from a traditional relational database and create your schemas. So here in this example, I have a singers table and an album table, and I just create that with strongly typed string or integer and things like that, define primary keys. Now, there is a feature, since this is a distributed database, there are a couple of things that are not available in Google Cloud Spanner compared to a traditional database system. Things like a referential constraints. But we have something where you can optimize your access patterns. And that is something that we call interleaving. So this is a technique to basically physically interleave child tables into parent tables. By that, you gain data locality. So you can actually group data together and make sure that queries, if you do joins a lot on like the parent table and the child table, that these queries can be answered by one node or only very few subset of nodes. All right, so how does it look like? How can you actually create interleave data tables? Here in this example, we have like our singers table that we saw from the example before, and then we have the albums table, and you just say like interleave in singers. What's really important here is that you share the primary key of your parent table. That is really important so that the interleaving actually works. I want to tell you that be a little bit careful with this. Interleaving means like that all the data in your parent table and child table end up in one split. We talked about splits earlier. One split is managed by one compute node. So if you have one row in your parent table, all the stuff, like all the data from your interleave table that qualifies for this primary key ends up in the same split. So if you have a large child table onto one row of your parent table, you might run into limits of like read-write capacity and also storage capacity. So be a little bit careful there, especially also for scalability reasons. A really, really cool feature about Cloud Spanner, which was really important for us when we adopted it inside of Google, was that we have no downtime schema changes. So what you can do with Google Cloud Spanner, you can actually alter your table, add tables, add indexes without any downtime. And I'm going to show that in a second as well. All right. So how can you actually get started with Google Cloud Spanner? So your first stop will be cloud.google.com/spanner. So this is our entry page or setup page where you can go in and learn about Cloud Spanner. You have links to the docs, but you find also a lot of the things that I just talked about, like comparison between Cloud Spanner and traditional databases, as well as NoSQL databases. We talk about use cases, and you find all the way to the bottom also some use cases and like studies around like Google Cloud Spanner. So I really can recommend to read the Quizlet blog if you're coming from a charted MySQL database, you want to know how Quizlet did the de-sharding into Cloud Spanner. This is a really good blog post, very technical. All right. So you get started in the Google Cloud Platform console. So console.cloud.google.com. And there, this is the home screen that you see here. Now, you have multiple options to go to Cloud Spanner. You either use the search box in the top. You can actually go to the search bar by hitting / as you might be familiar from Vim. But you can also use the hamburger symbol here in the left upper corner, and then go to Spanner. You find it somewhere in our drawer. You go to Spanner, and there it is. I have already one instance created. I'm going to talk about it in a second, but let's create an instance first. So you click on Create Instance. You give it a name. We say Cloud OnAir. It fills in the instance ID automatically. You can change it if you want. Then you have the opportunity to choose between a regional or multi-regional instance. So regional is basically a Cloud Spanner instance distributed across 3 zones in one region. Multi-regional gives you the opportunity to distribute your Cloud Spanner instance across multiple regions, up to a global configuration where you have the read-write replicas in the US, and then you have read-only replicas, for instance, in Europe and in Asia. All right, so we're going to choose and use US Central 1 here. You see also on the right side what US Central 1 configuration is, like all the API names, replicas, how many replicas you get. Our SLA for a regional instance, it is 4 nines of SLA. And to be qualified for the SLA, you need to at least have 3 nodes running. So I'm going to do 3 nodes here. You're going to see like what the cost is per hour for the nodes, and then also the storage cost. You click Create, and within seconds, literally, you get your own instance. Now you can start and create your database here and create a schema and everything, but I want to show you how to do this programmatically. So let's switch over to my IntelliJ instance. And I'm going to show you how to get started. So I choose for this session to show you the Java client. So to get started with the Java client, you have to either use Gradle or Maven. In this case, I use Maven POM file. And you basically select the Google Cloud Spanner client library for Java, currently in version 0.34, 0 beta. You have to import also the Guava library, and then the Google authentication to authenticate against Cloud Spanner. So it's actually very simple to get authenticated. If you run your client on a GC instance or from your laptop, which is set up with gcloud, which is our SDK, which comes with a CLI and everything, you can actually use the authentication context of either your GCE instance or your laptop that is already authenticated. So I'm authenticated against my project with my laptop. And to use the authentication there, I just do google.credential.getApplications default. One line, All right, I capture some exceptions here, but basically it's one line you authenticated. Great. So next thing that I need is I need the instance in my project that I want to talk to and the database that I want to talk to. So here in this case, I talk about Spanner Cloud on Air, the instance that I just created, and I'm going to create a database with the name demo. So let's jump into create database. So for the create database, we basically have to get a database admin client. So we get that from our Spanner library, we get the database admin client, and we say like what is the instance ID. I filled that into this function, and I want to also know the database ID. So what you see here is I actually create a database in that instance with the so in my Spanner Cloud on Air instance with the database name demo, and then I define the DDL here, so the schema. And I recommend everybody, like if the first schema that you create with your database, create it right away with your data, with your database. If you create it after your database, it will take a while. Schema changes are not as fast as like queries and things like that, so they can take up to minutes. And depending on if you create indexes that need to be backfilled, it can take hours or days. All right. So here in my case, I'm creating an account table with 3 columns, account ID, name, and email, and I create an address table, and I interleave all of this. So with this interleaving, I do the co-location, and I also have that one feature that I actually can do a delete cascade. So if I delete the parent row, I actually can make sure that all the addresses in my address table for that parent row are deleted as well. So let me run this. This should take only a couple seconds. Now, the setup of the client takes a couple of seconds, so this is not like coming back right away, but you see down here that it actually finished. So we can go back and check if our instance actually was created, and we see we have our demo database. All right, very cool. So now with this demo database, I can do things like query. I can see the schema. You see down here that I showed the schema. I see my indexes. I can run queries. I'm going to show in a second. And I can inspect these queries, see like query plan, see like where is time spent, optimize my queries, things like that. I also have features in the console where you can actually directly add data in the console, in the cloud console. So if you want to insert data, edit data, or delete data, you have the possibility to do that directly from the console. Especially good if you do some testing, things like that. All right, so we have created the database. So let's go back to our Java program. And the first thing that I'm going to do, I insert some data. So let's go to the insert. What you can see here is we are creating a list of mutations. So mutations are basically where you group any kinds of changes for the database together. So in this case, I'm building actually insert mutations where I insert a bunch of data into my account table as well as in my address table. I want to point out one thing. I'm using here a ID and which I declared as string 32, and that's nothing else than I use a UID version 4 and then convert it to a hex. And by that, I basically have a string with 32 byte. So why do I use UID? In a distributed database, you don't want to use something that is monotonically increasing or decreasing. The reason is that we split the tables by ranges, by primary key. And if you have something that is monotonically increasing or decreasing, you always end up in the first or in the last bit, by that overloading the node that is responsible for that bit. So if you want to get the best out of your instance, the best out of Cloud Spanner, you want to distribute your load as best as possible. So that's why I'm using a UID as a primary key here. So let's run this. And we're going to go back and see if this data was actually created. So now in my address table, I should be able to go to data, and you see that I have some data. OK, great. The next thing that I want to do is I want to do a read-only. So in my read-only, what I do is I create actually a read-only query. This doesn't create any logs. In this case, I'm just selecting the name and an email from my account data and check where like the country is in Germany. So let's see if I actually have some data in there that is from Germany. So let me run this. Really, to point out here, what is important is that this, like, you declare a single-use read-only transaction. By that, we know that this can be log-free. So we don't need to acquire any logs. As you can see down here, I have 2 users in my database that are living in Germany. All right. The next thing that I want to show is a read-write transaction. So in a read-write transaction, this is a little bit more complicated. So in our Spanner client, in the Java library client, what we provide is actually the rerunning of transactions if they fail. And we do this by providing a transaction runnable, so to say. So what we do here is we're creating a read-write transaction, and we provided a transaction runner. And in this transaction runner, I do my transaction. So what I'm doing here is I'm executing, I'm running a select statement, checking for all accounts that have my email address, and then updating the name in that account. And then I bubble this together and send it to the transaction. So if I run this, this should change my data. We can have a look at the account if there's anything changed to Spanner Guru. And as you can see here, we have the name changed to Spanner Guru. All right. So one note to the mutations. Mutations are important to know about because there's a limit in Cloud Spanner. So Cloud Spanner has a limit of 20,000 mutations per transaction. But what is a mutation in this context of the 20,000 limit? Mutation is actually any change on a cell level in Cloud Spanner. So as an example, if I have a table with 5 columns and I insert a row in this table, then I have 5 mutations. Now, if I define an index on that table, which indices another row, or let's say another 2 rows, then and I insert a row into my table, then it's actually 8 mutations. Right? So be aware of that. If you see the limit of you reach 20,000 mutations per transaction, that this is not 20,000 rows. It is actually rows multiplied by how many columns in the row plus in indices that you have. All right, last but not least, I'm going to clean up, but I'm going to do that later. All right, one thing that I wanted to show you really quick is I have actually an example database here. And that example database it's imitating like a ticket sales platform. Imagine like a global ticket seller who sells tickets to events all over the world. We did this test with a database of 80 terabytes of data, so something that wouldn't fit in a traditional database. And we did the test also with transactions to a limit that wouldn't fit in a traditional database. Now, I have a little smaller one here, but I want to show you, this is a query to get actually seat availability of all events that are happening today from 9 a.m. when this cloud session started, the Cloud on Air session started, to tomorrow at 5 a.m. Right? So, and then I'm looking for all the events that are happening. And I'm also checking how many seats are available and how many seats are available in total and things like that. So what is remarkable about this query? You don't have to think about charting or anything. This is just a query how you would see it in a traditional database. No specialties about charting or things like that, distribution. This is all handled for you. And you can also, right here in the console, get an explanation of your query, see the query blend, see how many rows were scanned, how much time was spent, and you can optimize the query with this information. So it's really, really powerful. All right. So for the last couple of minutes, let me talk a little bit about use cases in these industries and verticals. So where does Cloud Spanner help meet business goals? There are 3 things that are really important to mention here. So one thing, as we saw, Cloud Spanner uses traditional tools in the sense of what you are familiar with from traditional databases. So it has SQL, it has ACID transactions, so you don't need this logic in your application layer, things like that. So you can actually tap into existing resources. Developers that are familiar with relational database, they have a very easy transition to Cloud Spanner. Another thing is, with Cloud Spanner, out of the box, you get performance and scale and high availability. The way that Cloud Spanner is set up, it is high available and has this disaster recovery mechanisms built in. You don't have to worry about that. All of this is done by us, up to 5 nines SLA that we provide for that. You have regional and multi-regional instances, low latency transactions and reads, and as mentioned, simplified operation. Fully managed for you, a couple of clicks, and you set up with your own instance that you can interact with, where you can write data and read data from. So what are a couple of business use cases that you can look into? We look at 4 main categories here, or themes I want to talk about here. So the first one is transactional consistency over a database that is growing a lot. So imagine you have a supply chain management or an e-commerce platform, and you have a lot of data that you put in your database. So you outgrow basically on the storage side your traditional database systems. Now, what you can do is, we talked about this, sharding or go NoSQL, but you lose the transactional consistency or have it really, really difficult and have to build that into your application, which is very error-prone. A second one is scale for reads and writes. So imagine you have a telecom or a billing or a gaming company. It does all kind of actions that are happening on your gaming platform, or for instance for a telecom company, all kinds of calls that are going on need to go into a transactional system. Now, usually where you top out on is the reads and writes that you can do on your relational database. Spanner, the way it is set up, scales horizontally for reads and writes. So you get strong consistency and scale for reads and writes for that. Another use case that we see, or theme, is global data. Just imagine you have something where you want to have the data all over the world. You are a global company, and you want to have access to your data from all over the world. And again, you want to have a consistent view on this. Imagine financial services, banks that are operating globally, or insurances or global call centers that need actually a view which is consistent all over the world. And the third one is database consolidation. Just think logistic or manufacturing, where you have the supply chain again, and you want to consolidate the data from multiple data sources into one database. Again, to have a strong, consistent view on this, but also the ease of use, because you have only one system that you have to manage and to deal with for your data and your applications. All right. I want to close out with a little bit step out and do an overview of where Cloud Spanner fits in the Google Cloud Database portfolio. So I talked about Cloud Spanner and all the goodies that Cloud Spanner come with, but we understand that there are other use cases where other databases are more suitable. So if you look on the left, you have our App Engine Memcache, which is good for mobile development and app dev, things like that. We have our relational, where we talked about Cloud Spanner just now, and we have Cloud SQL, which is a traditional database system in the flavors of MySQL or Postgres, where you can scale vertically. It is managed again. We manage for your read replicas, and we can also do master-master replication. This is good for applications where you are good with a vertical scalable system, and maybe you transition it or migrate a system which was running before on a MySQL or Postgres. We have also our non-relational flavors. So you can look at Cloud Data Store, which is a document-based database. It's very scalable. Big companies that are well known around the world have built on Cloud Data Store and have scaled from a couple users to millions, hundreds of millions of users on Cloud Data Store. We have Cloud Bigtable, which is backing our search, for very fast reads and writes. You can use Cloud Bigtable. It is a row-based database. So you have transactions on row level, but not across row level. And then we have Cloud Storage, which is for our blob storage, so to say. With Cloud Storage, we have different tiers based on how often you access the data. You can save some money on there. What is really cool, Cloud Storage is also backed by Cloud Spanner. So if you do an LS on Cloud Storage in the US and in Europe, you always get the same view. So all data that you commit to Cloud Storage, be it a video file or any other file, you will get a consistent view on the data that is in Cloud Storage. And last but not least, really amazing product is our BigQuery product, which is our OLAP, so data warehouse product, where you can load terabytes and petabytes of data into BigQuery and query it in minutes or seconds or minutes, actually. Like very powerful, very powerful query language. You have UDFs in BigQuery that you can use. So please try it out. If you want to do data analytics, have a look at BigQuery. And with this, I want to close for a second. We're gonna switch into the Q&A session after we regroup a little bit. So please stay tuned. We will get back with the questions that you asked. So they have on the right side, you should see some the Q&A platform where you're able to actually put questions in, and we're gonna answer a couple of those in a minute. Thank you very much. All right, hello back. We got a couple of really cool questions from the audience, so I'm gonna go through them. You should see them on the screen, and I'm gonna go through them one by one. But the first question that we have is, what's the difference between MySQL or Postgres or other relational databases and Spanner? So if you look at traditional databases, relational database like MySQL, Postgres, or any of the big vendor databases, they are like by default a vertical scalable system. Cloud Spanner, on the other hand, is a horizontally scalable system without giving any of the nice criteria up from a relational database. So we have strong consistency, we have asset transactions in Spanner, but we are horizontally scalable. So you can load terabytes, hundreds of terabytes of data into our database. You can have millions of reads and writes with Cloud Spanner. So that is the main difference from Cloud Spanner and MySQL. The second question was, is it possible to migrate from current SQL systems like MySQL to Cloud Spanner? It is definitely possible to migrate, but I have to say, like, this is not a lift and shift migration. So because Cloud Spanner is a distributed system, there are some things to be aware of and that need to be considered when migrating from a MySQL system. So one of the things is we are currently not supporting UDFs, so user-defined functions, triggers, or stored procedures on Cloud Spanner. So if you use any of this, you need to like re-implement these things in an application layer, but you get all the scalability and the asset transaction on Cloud Spanner. Other than that, you can currently migrate from SQL systems by using our client libraries. So you export from your existing database and then create a schema, modify the schema to be suitable for the distributed system, and then load your data into Cloud Spanner and run it there. The third question was, why not just use a NoSQL database? One thing, consistency. So if you look at normal, like traditional NoSQL databases, then the first thing that you give up is consistency. Most of the NoSQL databases, to achieve the scalability and the high availability, they are giving up strong consistency. So many of these systems are eventually consistent. And what that means is, as an example, you have the World Cup, and the World Cup is published to a database. And somebody goes onto a website and checks the score of the World Cup and sees, OK, it has finished, and this country won the World Cup. And then the friend that is sitting next to you, you tell them, like, hey, like this country won the World Cup, and the friend is going to the website, but he's going to a different replica of your NoSQL database. And for him, the game hasn't finished, right? So the data hasn't replicated to all replicas. And so two people can see different results. In Cloud Spanner, this cannot happen. If the data has been committed, all replicas have that data. And so if any requests are coming in from all over the world, everybody will see exactly the same data. The fourth question is, does Cloud Spanner have client libraries? Yes, we do have client libraries. We have client libraries for Node.js, Java, PHP, Go, and Python. And we are working on a lot of other ones. We have also C#. We even have the C# ORM connector already available. And the fifth question was, does Cloud Spanner encrypt data? So Cloud Spanner, all the data in flight and at rest is encrypted on Cloud Spanner. So if you load any of your data in there at rest, all the data is encrypted. Now, if you want to have encryption on top of that, you need to put this encryption on top of that. While we're talking about encrypting data, I want to talk about like the permissions that you can set on Cloud Spanner. So we have an identity and access management system in Google Cloud Platform. We call it IAM. And you can actually set IAM roles up to the database level, who's allowed to access your database, read, write, and execute queries, things like that. All right, see if you have some other. Okay. Cool. I think that's all the questions that we had. Do we have any other questions? I see there are a couple of other questions. Should we answer them or should we? Okay, we're gonna answer actually the other questions offline. We're gonna answer them. So please stay tuned. If you have asked any other questions, we're gonna definitely answer them after the session. The next session will come out of our Kirkland office in Seattle, and Kirill Toprin is talking about the right storage class to optimize the performance of your workload. So please stay tuned for the next session out of Seattle. Thank you very much for your time, and I hope you enjoyed this session.